So first we need to talk about the definition of a regular prism. A regular prism is a prism with bases that are regular polygons. Okay, that doesn't help us unless we know what a regular polygon is. So what's a regular polygon? A polygon that has all segments that are equal and all angles are equal. Okay, so regular polygon has all equal sides, all equal angles, equilateral and equiangular. Okay, then the second one that we need to be aware of is the definition of a right prism. A right prism is a prism with the lateral edges that are perpendicular to the base. Okay, the edges and the base form right angles. You can use your perpendicular symbol as you're taking your notes. The lateral edge is perpendicular to the base, both bases. An oblique prism is a prism that is slanted. So think of the Leaning Tower of Pisa. Okay, slanted. So it's not straight up and down. It's not perpendicular to the base. The lateral surfaces aren't. Okay? Looks like it's leaning. Okay, we're good with this slide? We're moving. We got to keep going. A lot to talk about today. The sum of the areas of the faces of a polyhedron help you find the surface area. Okay? When we're talking about a surface area, when we're talking about the surface area of a prism, we want to know its coverage. So I've got a candy box up here. When we're talking about surface area, I want to know how much area the front face occupies, the back face occupies, both sides, and the top and the bottom. It's empty. Okay? So we're not interested in how much space it occupies, just how much coverage we need, how much ink has to be used to cover this packaging material. Okay? So for the front, what are we going to do? We're going to find the area of the front by taking 14 times 6. So even though this is listed in the back, it's also the same as this side. So back and front will be the same. 14 times 6 is 84. 84 for both. The right side has dimensions that are 6 times 4. 6 times 4 is 24. It will have the same surface area as the left. And then we have to find the top and bottom. So 14 times 4 will get you the bottom and the top. 14 times 4 is 56. So 56 for top and bottom. When we add all 6 of those areas up, we get our total surface area. That total surface area is 328 centimeters what? Squared, because area is always in centimeter, or is in square units. Okay? So the total surface area is the total area of all the surfaces put together. Should be adding. Add the 84 plus the 84 plus the 24 plus the 24 plus the 56 plus the 56, which is kind of tedious. You could take 84 times 2 plus 24 times 2 plus 56 times 2. But still kind of tedious, right? Okay. So would you like to see a shortcut? Okay. So shortcut. Okay. The shortcut says if you want to find the surface area of a figure, you can first find the lateral area and then find the total surface area. The lateral area is found by finding these surfaces that are not bases. So we have a blue base, right? What kind of figure is this? A triangular prism, okay? It has two bases. Both are triangles. So when we want the lateral surface, we're talking about those three sides that are not those two bases, those three rectangles. Okay? To find the lateral area, we're finding the area of the faces that connect one base to the other. Okay? So the lateral area is the area of the faces that connect one base to the other. And its formula is on your sheet. It's capital L equals capital P times lowercase h. And there's a reason for the capitalization. In these formulas, if you see a capital letter, that means you have to do some calculation to get that value. If you see a lowercase letter, it's just one of the sides, one of the measurements of that polyhedron. Okay, so lateral area is something we're calculating, and it's going to be equal to P, capital P times H, where capital P is the perimeter of the base, and H is the height of the prism. Okay, so put a little star beside height of the prism in your notes, because we have to be careful not to take the height of the base. We want the height of the whole prism. The height of the whole prism is the distance between the two bases. Okay? So, once we've found the lateral area, the area of the orange, then we're going to add on the area of the two bases to get our total surface area. And the surface area is often denoted as either T, capital T, or I've seen some books call it capital S, capital A. And it's equal to that lateral area, the perimeter of the base times the height of the prism, plus 2 times the area of the base. Okay, where capital B stands for, capital B stands for the area of the base of the prism. It will be, especially when we get to octagonal prisms and things like that. Okay. Sorry, it still didn't do it. It pulled off a okay. So P was the perimeter, right? And H was the height. Okay, so we're ready to calculate. So to find this, on the bottom toward the right, bottom right of your notes sheet, we have a P, L, B, and T next to this picture. So first we have to find the perimeter of the base. So you told me that the bases are triangles. Okay? To find the perimeter, capital P means add up all the sides on the base. 8 plus 8 plus 11.3. So 16 plus 11.3, 27.3. Okay? Now we have to take that times the height of the whole prism. So we're taking that 27.3 times the height of the whole prism. The height of the whole prism is 7, because 7 is the lateral edge that's connecting the two bases. Okay. So we're taking 27.3 times 7, 91.1. Okay. So L equals 191.1. And then we want to find the total surface area, but to do that, we have to calculate the area of the base. What kind of triangle do I have for a base? A right triangle. So my leg and my other leg are both 8, and my hypotenuse is 11.3. How do I find the area of a triangle? Base times height divided by 2. So I need to take the 27.3. Okay. So base times height divided by 2 will be 8 times 8 divided by 2. So 64 divided by 2 is 32. So now to find my total surface area, I take my lateral area, my P times H, plus 2 of those areas of my bases. So I need to take 191.1 plus 2 of these 32s. So 191.1 plus 64 gets me 255.1. And what will my units be? Inches squared, because area is always in square units. Yes, sir. The 191.1 came from taking my perimeter, which was 27.3 times the 7. Forgot to put 7 over here. Times my height. Okay. Had to find my perimeter of adding these guys up. And I had to take that times the height. The height of the prism is 7. Because that's the lateral edge that's connecting the two bases. Okay? Other questions you have on this slide? Maddie, are we good? Okay. Anybody need more time to write? Okay, give you a couple more seconds. Okay. So another example of finding the lateral area and the total surface area involves the next figure on your paper below it. What kind of prism is this? A trapezoidal prism. Okay, so you've identified the bases as being trapezoids. Okay, so to find the lateral area, and I highly, highly, highly recommend writing this down every time. Write your formulas so you remember them. It helps you memorize them. Okay, there's something about writing that helps us connect it to the motor, the fine motor cortex of our brain, and helps us make those connections. Okay, so capital P times H. Okay, so we've got to find the perimeter of our base. All right, this is a trapezoid for a base. I have 8 down here, 7 for this side. I have, how tall is this one? No, this is not 7, but 9. Do you see how it's the same as this one over here? And then finally, 12. So to find the perimeter of my trapezoid, I need to add up all the sides. Every single face, every single side of my trapezoid. Okay, so you're adding 12 plus 9 plus 8 plus 7 and getting 36. I would write it down. It will help you keep track of it. What's the height of my prism? Be careful. What's the height of my prism? The height of my prism, not the height of my trapezoid. The height of the prism is the one that connects the two bases. So this is going to be 10. This is my height of my prism. Okay. So what's 36 times 10? 360. That's my lateral area. Those are all of my rectangles. Okay. I think that's faster than taking 10 times 9 and 12 times 10 and 7 times 10 and 8 times 10. Okay. Now to find the total surface area, you need to take the lateral surface area and add on 2 bases. So we're taking that 360 and we're adding on 2 of these bases. So first we have to find out what our bases are. Anybody remember how to find the area of a trapezoid? Something times height, right? It's actually got 2 bases. Those parallel lines are your bases. So the area of a trapezoid is always going to be the sum of the bases divided by 2 times the height. So you find the 2 parallel lines, that's the 8 and the 12. You're adding them up. You're dividing by 2, basically averaging the bases. And you're taking that times the height of the trapezoid. Okay. So what is 12 plus 9 divided by 2 times 6? I'm sorry, 8 plus, my fault, 8 plus 12 divided by 2 times 6, 60. So we have 2 of these bases that are 60 in area. So 2 times 60 is 120, 120 plus 360. Centimeters squared. Area is always in square units. Okay. Next, we're talking about the volume of a prism. So I've saved the easiest for last. The volume of a prism is the amount of space that the solid takes up. The volume of a prism is the amount of space that it takes up. Braxton, where are your notes? Aren't you taking notes? Be quiet at least and not distract others. So that's how much space is occupied by this box. Okay? How much space this occupies. So how much space does my candy box have inside of it to hold candy? Mm-hmm. And this is the easy one. To find it, you simply take the area of the base times the height. Capital B, again, is capitalized because you have to do some calculations here. So the area of the base times the height. So on a rectangular prism, because all the sides are rectangles, you can decide which one you want to be your base. Okay, so which one should we have be our base? This side. Okay, so we can use this guy. This can be our base. It does not matter on a rectangular prism which one you want to be the base. But I recommend shading it so that you can keep track of what your base is. Okay. So how do we find the area of a rectangle, Braxton? How do we find the area of a rectangle? length times width. Okay, so we want to take the length times the width. 4 and 6 are our length and our width. So our area of our base will be 6 times 4. And then what's the height of our prism? If this is the base, what's connecting these two bases together? 12. So we're going to take that times 12. So 24 times 12 is going to get us 288 centimeters, what? Cubed, because we took 6 centimeters times 4 centimeters times 12 centimeters. Centimeters times centimeters times centimeters is centimeters cubed. That's our volume. If we filled that box with water, that's how many cubic centimeters of water would fit in that box. All right, we good with this one? We save the easiest for last. Volume's a lot easier than lateral area and total surface area. Okay. All right, next example. Is Cavaliers Principle. You don't have to write all this down. Just think and focus for a moment. Okay? You all played Jenga, right? Okay. So, or at least you've seen Jenga before? Yep, that's with the blocks. Okay? So if I stack them all nice and neatly, it has a specific volume, doesn't it? Length times width times height. Okay, or the area of the base times the height. If I shift it to one side, has the volume changed? No. That's all Cavaliers Principle is saying. Is if you have two surfaces, two solids, with the same surface area for their base and the same height, it doesn't matter if one's oblique or one's right. They're going to have the same volume. Okay, does that make sense? So no need to write this down as long as you're okay with the fact that when we take a deck of cards and we have them all stacked up nicely, but then we slide them over a little bit, they still have the same volume, right? Okay? So nothing has changed. So this right prism, this right hexagonal prism, and this oblique hexagonal prism, if they have the same area of their base and the same height, are going to have the same volume. Okay? All right, let's do one more quick example of volume. 2 times 5 times 4. So 10 times 4, 40 meters cubed. Okay? You can, except the problem becomes what happens when we deal with this then. Okay? Okay. The problem is we first have to find our area of our base. You could. But what's your length and width? What's your length and width? It won't work. Nope. Okay. So great question came up. Can we just say that this is really just half of a prism? Okay, a rectangular prism. Okay. So we could find the area of that rectangular prism and divide by 2. Okay, and that would work if you use the right sides. Okay. So the problem is everyone will want to use this 12.5. They want to say 10 times 8 times 12.5 divided by 2. And that won't be right. Okay? Because in order to find the area of your base, you have to find the area of this triangle. Okay? Everyone's okay with this being 10, right? This is 12.5, but what's this? Because if you're looking at a triangle, to find the area of a triangle, you have to take the base times the height divided by 2. I'm okay with this being the height of 10, and we don't know the base. That's 12.5. So how do we find that base? Pythagorean theorem. Okay, Pythagorean theorem says a squared plus b squared equals c squared. So we're going to take 10 squared plus b squared and set that equal to 12.5 squared. So 100 plus b squared equals, what's 12.5 squared? Point what? So when we subtract our 100 from both sides, we'll get 56.25. And we'll have to take the square root, and b becomes 7.5. Okay? So this little guy here is 7.5. So to find the area of my base, I have to take the 10 times the 7.5 divided by 2. Because that's the area of a triangle. So it ends up being 156.5. And then I need to take that times the height of my prism. And the height of the prism is how much? Okay. The height of the prism is 8. So we get 156.5. I didn't get that. I got 37.5. Okay, so 37.5 times my height of my prism. 10 times 7.5 divided by 2. Okay. 75 divided by 2 is 37.5. Okay, we're going to take that times 8, and we will get 300 inches cubed. Okay, you bet. Okay. The next two examples on your sheet are nothing more than finding volumes again. But do you notice that they're using Cavaliers Principle? Okay, so they're a little bit easier to actually see which is the height of the whole prism. Do you want to see either one of them worked, or are you good for now? We're good? Okay, let me get you your assignment. I should record this and play it back for posterity, but I highly, highly, highly recommend writing your formulas every single time, because it will help you memorize and get these down. You'll have a lot of formulas to know when it comes to test time. And writing them down repeatedly helps you memorize them, helps you learn them. Okay. Then we can't get enough of them that come out to nice, neat numbers. There's always going to be decimals somewhere, unless we only deal with rectangular prisms. Okay, let me stop recording here, and away you go.